Welcome to today's deep dive into one of the most fascinating fields of modern science, particle physics and data processing, specifically the Large Hadron Collider. It is the most powerful particle accelerator ever created. For those who don't know, the Large Hadron Collider is a gigantic circular machine designed to smash particles together at incredibly high speeds. The LHC allows scientists to uncover the deepest mysteries of the universe. Operated at CERN, the European Organisation for Nuclear Research, and is located in Geneva, Switzerland. This ginormous machine is 27 kilometers long and over 100 feet under the Earth's surface, stretching beneath the ground in a massive circular tunnel. Inside this circle, superconducting magnets are used to accelerate particles to 99.99999% the speed of light before colliding them together. These collisions replicate the kinds of high-energy conditions that might have existed just after the Big Bang, each collision giving us 14 TeV. To put this in perspective, 1 TeV is 1 trillion electron volts. Since it was first built, the LHC has been at the heart of numerous discoveries, including the existence of the Higgs boson, or the God particle, in 2012. The LHC is about much more than just smashing particles together. Behind the scenes, an incredible amount of data is generated during these experiments. To give you an idea of the scale, the LHC produces around 1 petabyte, which translates to a million gigabytes of raw data every second. Processing this data would be challenging, but fortunately, scientists don't need all of it, as most data is irrelevant to their research. So the data is filtered down to about 100 gigabytes per second of relevant information. The LHC's distributed network for handling data is called the Worldwide LHC Computing Grid, or the WLCG. The WLCG consists of thousands of interconnected servers working together to store, process, and analyze the LHC's data. The WLCG is a multi-tiered system distributed over 170 computing centers in 42 countries. The heart of the operation lies at CERN, which stores the Tier 0 data centers. This is where the raw data from the LHC's detectors first arrives. At this stage, the data is processed and replicated so that a backup is created, safeguarding it against potential losses. Once the initial processing is complete, the data is transmitted via high-speed optical networks to a set of Tier 1 centers. These centers serve as large-scale storage facilities and also perform additional data processing tasks. From there, the data is passed down to Tier 2 centers, which are smaller in scale, but they are more abundant. Tier 2 centers are spread across universities and research institutes worldwide, allowing scientists to access the processed data for their studies. This hierarchical structure ensures that the data is handled efficiently at every stage, from initial processing at CERN all the way to distribution to individual researchers. To keep all of this working smoothly, the LHC relies on a variety of specialized technologies and protocols. TCP/IP, the protocol that the entire internet runs on, is used for general data transfers, while other specialized protocols ensure the rapid and secure movement of vast amounts of data. The connectivity between these centers is crucial because delays in transmitting or processing data could slow down research efforts. Imagine having to wait for days or even weeks to get the results of a particle collision, only to find out that the data you're looking for is incomplete or corrupted. To avoid these issues, the WLCG is designed with speed, security, and redundancy in mind. Speaking of security, it's important to realize that handling this kind of data isn't just about moving large files quickly. It's also about keeping that data safe. The LHC's data is invaluable, and it's critical that the information remains both confidential and intact throughout its journey across the network. Similar to high-security financial networks, the data is encrypted as it moves from one location to another. Only authorized
think I'm gonna be
individuals
having
and
a
systems
Me
can
and Sir,
access this
sorry,
data,
Dom.
thanks to
We're
strong
missing some
authentication
settings, right?
mechanisms and security
But
certificates.
Does it work now?
yes.
When you consider the sheer scale of the LHC, it becomes clear that this isn't just a triumph of physics. It's a triumph of modern computing, telecommunications, and data management as well. The LHC represents a collaboration between countries and industries all working together to answer some of the most profound questions we have about the universe and existence. As the LHC continues to operate, pushing the boundaries of what's possible, it stands as a reminder that science isn't just about the theoretical equations or laboratory experiments. It's also about the behind the scenes work that allows those discoveries to be made in the first place. Without the sophisticated computing systems in place, the groundbreaking physics happening at the LHC would be impossible. And as we look to the future with plans for even larger colliders and more advanced experiments, the importance of systems like the WLCG will only continue to grow more and more important.